Yep.
All right, so we've discussed in a couple of previous videos how to do just basic printing of messages from Python, how to set entity locations, rotations, how to get references to entities in the first place. But now let's talk about something that is probably like a burning question for a lot of people, and that's the global variables that we have access to. So they include the SimEntity. That's just an entity that's kind of like a global variable for everything. And there's some SimGlobals functions that you have access to as well. So again, boilerplate here, don't touch it. Your own custom imports, whatever they might be, that goes here. We have some functions copied over from the previous systems that we've written. We've just copied that. And then we have a copy of that property quaternion function, so we're still going to be doing that. But let's get into how do we use the SimEntity, right? So every sim config has a SimEntity. Let's take a look at it in here. We'll open it up. And this has the parameter of time. Time is basically just a structure of what, like, when is this sim running? You can use the current time. That'll use the time from your computer. You can set the time scale to whatever you want. 1 times is real time. And then you can also say, well, I don't want to use the current time. I want to use my own custom time. And you can set something, in the past. You can set something in the future, whatever you want.
This is particularly useful for when you have the entire solar system or really any part of the solar system inside your simulation. So then you can do, say, like set my time to 2027 or something like that into the future. This is when I am, say, landing my lunar lander on the moon. Now I want to evaluate my lighting conditions. These are particularly useful because inside space teams we have the entire solar system with the correct places. We use Spice to do that
Yep.
for good
But
lighting.
basically, the point is, right, you can set the time whatever you want, and you can use that to your advantage. You can rerun the same sim over and over and over without having to worry about uh, time stepping
Yep.
forward. Yeah,
You can play God of Time here. It's pretty nice.
exactly. Yeah. So other stuff in here, everything beyond time is up to you within the sim entity. You can use the sim entity however you want to set whatever references you want, and this will be accessible from anywhere within space teams. So the point here is, right, we can access this sim entity within any system, within any entity, without having to have a direct reference to the system or the entity or whatever, right? So we have a reference to entity one and to entity two over here. Both are defined again within the sim config. Here's entity one and here's entity two. And we have references to them passed in by the standard entity ref notation here, right? And now we can do back in our example system here, right, is we can use that to get an entity ref for that same entity two that we did in the last system. If you recall, we did it this way. We did entity two ref from system, and that was get the system and then get the param. We can do the same exact thing from the sim entity. That's get sim entity and then get param entity ref, and then type in the name of that parameter. Do be careful here. Don't type in whatever the name of the entity is. Type in the
Remember to type the
key.
key.
Always type in the key when you're getting a param, not the value. Okay. So that's basically how you do that. And then just a quick note here on this syntax. Some people might not be familiar with that in Python. This is basically to allow it to recognize what type it is. Otherwise, if you don't do that, then your interpreter is going to have no idea what type this is. It knows here it's an entity, right? But otherwise, it wouldn't know that, and you wouldn't get access to all the functions and all the correct syntax for an entity, right? So again, this is a reference to entity two, which means we can do the exact same stuff that we did in our previous system because that was operating on this loop of four entity and entities, and then entity two was a direct reference. Well, we can do the same exact thing here, except replacing it with the entity two reference from SimEntity. And you can see it works the exact same, right? There's no difference here, right? This is all the exact same code, basically some shorthand here and there, but it's basically doing the exact same thing, right? The important thing here is that setting some kind of entity reference from a system or from the sim entity, it's the exact same thing. It's still a reference to the exact same object within your sim, right? Um, Now, let's get into some of what the sim entity and what SimGlobals actually does here, and that's global functions, right? So these allow you to control the simulation directly. So be very, very careful with this, especially if you're doing it at runtime. For example, here, first example here, sim clock freeze. We have that commented for very good reason because it'll freeze the sim clock and it'll freeze the sim, right? You don't want to do that typically unless you're trying to pause the sim at some point. Uh, and here's the unfreeze, right? It's a very intuitive syntax, but be careful with when you call these because it will freeze your sim. It will freeze all the dynamics going on. And if something depends on a non-zero delta time, like this, for example, um, then it might break, uh, especially if that's zero at some point. Another way to set the sim frozen basically is set the time scale to 0. In this example, this is setting it to 2 times speed. This is 2 times real time, right? It's not 2 times the previous speed, it's 2 times the base speed, which is 1 times, which is real time. Okay. And that's how you do it here. We can probably uncomment this one. That's a pretty safe one to do.
Yep.
Um,
We'll
and
see
then
how that works.
Yeah, and then let's see if we want to get the current time, right? You just say SimGlobals underscore SimClock underscore get time now, right? And these are all available just by typing in, right, SC dot, and then you can say SimGlobals, and you can see all the different things you can do in here, right? So let's get out
You
of
might
that.
have noticed that there are some extra functions within the SimGlobals, but we will be creating extra videos on those more specialized functions. But this is
Yep.
just some of the generalized
Yep.
functions.
These are probably the most useful ones for someone just getting started in operating a sim. So we have the time now. That's what the sim says the time is now, right? Which again, it's not your computer time. That's going to be your time that's specified right here. Okay. And then we can print it by just saying logger.info. Again, that'll print just to your log. It will not print to the screen. If you want to print to the screen, well, guess what? You use on-screen log message or on-screen alert. But that'll print the current time to the log. And you can also get the current time scale. Here we set it. Here we can get it, right? Uh, Again, we print it this way. Remember, anytime you print something, make it a string first, unless you're absolutely certain that it's already a string. And then this right here is how you get the base frame of the simulation. So every simulation has to exist in 3D space, right? It has to have some kind of inertial base reference frame, right? And this is what it is. It's SimGlobals get base frame. In the past, there was a get global frame function that I believe still exists in here, but it is deprecated. So don't use that. And then if we want to print it, right, we just print what that is. Okay. And then again, last thing in all these is to cycle the system at the specified frequency. So
Let's go ahead and run it. Let's
let's
go
run
ahead
it.
and turn our system on to true
Yep.
here, and
And
then we'll run it with the 2 times time speed that's been set up. That shows that's shown down below.
yep. So here we see once again, this is our system that we want to run. We'll set it to true. And just because it's also setting rotations, we'll turn it off. We'll set that one to false. And just to clean up how many prints are going on, we'll also set this one false. And we'll see just a quick reminder that all of these are on entity 1. So entity 1 is the one that's making sure all of these are actually running within our sim. Okay. And parameters are all the exact same as you've seen before, right? It's just the standard setup that we have here. So remember, always save your JSON. If you don't save your simulation JSON, the sim config here, it will not apply, obviously. But let's jump back into Space Teams and let's see how that works. All right, you can see for a brief moment there it was at 1 times, but now it's at 2 times time scale. Now, what you'll notice here perhaps is that um, this rock is spinning just at the same speed as before. Even though we set the time scale 2 times, it's still spinning at the same rate, and that's for a very good reason here. Even if we bump up the time scale, I'm hitting period here, but it keeps resetting it back to 2 times because the sim is running, or the system is running every loop, right? But let's say if I were to set it to 10 times or 100 times, that rock would still spin just as fast. So if we exit sim here, let's go back and let's figure out why that is, right? So when we set this time scale, we say nothing about this loop frequency hertz parameter, right? We have said absolutely nothing about it, okay? This is still at 60 hertz, right? So here it says 60 hertz. It's still at 60 hertz. When you set this time scale to 10 times, 100 times scale, you're not actually changing how fast the Python system is looping. In order to do that, you would have to keep track of a variable like current time. You could say, for example, before all this begins, you could say time equals SimClog get time now. And then after you sleep the DT seconds, you could say, okay, now get the time after the sleep, right? That's the next iteration time. And then you do the difference between those 2 times, and that becomes your DT. You keep the frequency that the system is running at the same. It's the same, DT that we have here from the loop frequency in hertz, but the time that you plug into your set rotation and anything else that's dynamics based, that would be the actual delta time between loops within your system based on the in-sim timescale, right? So um, yeah. So if you ever see that, if you ever see like, oh, it's not changing the speed that anything's going at, well, guess what? That's intended functionality, and that's how it works. You keep track of it yourself, and you set it yourself. So that's better for this one.